Okay guys, it's me Imad from Nelson Darwin Park Tech YouTube channel. In this video tutorial, we will learn about 1 to 4 demultiplexer within the multisim. As we know that demultiplexing is the reverse of multiplexing. In multiplexing, we need to take 4 inputs and there is one output. While in demultiplexing, we have 1 input and 4 outputs. With the help of demultiplexing, we can send data with the help of we can send data on 4 different lines is according to our control bit selection or configuration. So let's start it so that you will get a bit more better concept. So first we will go to our DC power supply. Okay, now this is our DC power supply. Okay, now after it we need to take our ground. Ground is very necessary to operate these type of semiconductor and logical circuits. Okay, after we have placed the ground, we need to go for some what's called is these switches, the dip switches. So we will go for our basic components. So we will go for switch and then dip switch 1. Okay, now this is our switch. First switch is for what's called is the first control bit. The second switch is for the second control bit. Third switch is for data line. Okay, that is D or data line. Okay, so this switch and third switch. So okay, now this one. Also drag this power source a bit so that we can adjust all the components. Okay, like connect it like that. So these are the 3 dip switches. Now we need to take our AND gates. For AND gates we need semaphore A LS 11. So these are the 3 input AND gates. So we can take 4 of these AND gates. Okay, like this and this and this. Okay, now on the output of these AND gates we will place indicators in order to show the data. So we can take this orange or red. Okay, we will use red, and then this red and this red. Now we can connect the output with the indicators. Okay, now 4 AND gates and 4 outputs. Now you need to combine all the first inputs of the AND gates. Just connect them out. Okay, like this. And we need to connect the lowermost key with these data line, with this data. So it is actually our data line now. Now what about the rest of the pins of the AND gates? Now we will make 4 combinations, like we will assume that, okay, it is assumptions that it is 0 0, then 0 1, then 1 0 and 1 1. we will assume that 0 0 0 is after the what's called is the NOT gate. So first we will place our NOT gate as well. So we will go for TTL and then NOT gate. So this is our NOT gate. So we will place two NOT gates here. These are our control bits, okay? And this is the technical point. So just focus a little bit that okay. Now after this AND gate, this NOT gate, we consider that it is 0 0, and we will connect both the inverted inputs to the first AND gate. So it is 0 0, that is after the NOT gates. For the next one, we will consider first as 0, connect it like that, and second with 1, like before what's called as the AND gate. Before NOT gate. So it is 0 1. Now then 1 0, 1 first must be with this one at this point, and 0 must be with this point, and the last one with 1 1, that is 0 0 0 1 1 0 and 1 1. So the last must be with 1 1. So as this line is going to 1, so this is with 1 and the second with 1, okay? So this is our complete circuit, okay? Okay, now we will go for our running simulation. So okay, now it will take 2 to 3 seconds to in order to run. Okay, now it's running now. Okay, now we can see that when it is 0 0, because both the switches are what's called as the at 0 0, means that both are not on, both are open. So our data will be going on the first output. Okay, now when it is 0 1, that is the second switch is on, then our data will be going to the second output, and when it is 1 0, then we can see that our data is going to the third output, and when it is 1 1, then the data is going to the fourth output. So rather than 4 to 1, it is 1 to 4 demultiplexer, because 4 to 1 is for multiplexing and 1 to 4 is for demultiplexing. So hopefully you got this concept. So thanks for visiting our channel.